Welcome back, my friends. We are in the Secret Messages project, the part one of it. I'm going to wrap up this entire series of videos for now by showing you what I call a bonus encoding and decoding. Now, this is not something that we are creating new. In fact, we are just going to combine the swap middle plus reverse. Remember, the swap middle itself was quite a weak encoding. We are now combining with reverse. Now, one of the things that this encoding does is that it makes the process of encoding and decoding different. Remember, in all the other encodings that we have seen, whether it's even odd swap, whether it's reverse, whether it's word reverse, whether it's swap middle, always we could use the same function for decoding. But now in this encoding and decoding, this will not be the case. We will in fact have to do slightly different operations on decoding. So this illustrates the point that most of the times decoding will be different and also gives us a chance to explore a little bit more here, right? So let's just do that. But let's just see what we are trying to do. So what we are going to do, like I said, is to combine swap middle and reverse. So my secret message will be found not just by swapping the middle part, but in fact additionally reversing it too, right? So I'm going to create a message which is say swap mid rev, and that will be first swap middle and then reverse this. Now in the decoding, right? In the decoding, I have to do both these steps in the reverse order. So which means that I have to first reverse this and then I can do swap middle. And this is where I'm saying that the decoding process will be somewhat inverted from the encoding process. Let's just see this ourselves by writing the code for this. So we already have these functions, so it should be quite straightforward to do. So I'm going to say, let's say def swap middle rev of x. Again, x is the input, so I come in here and I say, okay, look, first I want to say swap this in the middle, so I'll just call it say x swap is equal to swap middle of say x, so swap middle x, and then I want to maintain my notation that I've been using, so I'm going to say s is equal to reverse x swap. So s is another string, and now I can just say return s. Notice how we have used the previously created infrastructure to do this, and now it's going to do swap middle as well as rev, right? So let's just do this here. Let's say I come in here and I say x swap middle and rev is equal to we call it swap middle rev of x. So if I run this code now, I will get, I have a variable here available to me. It's called x swap middle rev, and that is given by notip luxi. Now notice here a reversal has also happened along with the swap middle, because we can compare this with say x swap middle. That was basically is cool Python. So now clearly this is a lot definitely harder to read compared to only the swap middle, right? However, we need to now decode this, but for decoding I must do exactly reverse. So I'm going to create a new function here. I'm just going to copy this and paste it here. So I'm going to call it, let's say def swap middle rev say decode. Now again, my input here can be called x because it's an input that's coming in here, but I'm going to have to reverse these two operations. So I'm just going to say x rev is equal to swap middle. I'm going to have to reverse first, sorry. So I'm going to say reverse of x, no, where x was the input. Now I come and say s is equal to say swap middle, right? Notice here that the order is different, and that's what makes it somewhat interesting. So I'm saying so x rev, right? And again I can return s because all of this is local to the function, right? So what happens is that now I can go and say I've got this, say let's say x, let's just do it again here, right? So I'll just call it x decode for now, is given by, because names are becoming a bit long, so I'm going to say swap middle rev decode, swap middle rev decode, and I'm going to say the function, the variable I should be using is this x swap mid rev, because this will be sent as an input to the function which will do the processing and it will return me back the processed value, which is the S value, right? Let's see, why is this giving me an error? I think this should be okay. X, so as a swap middle rev, okay, so I've got a mistake here. So it did not recognize this function, should decode. Now with this done, I think it should be fine. So notice here one thing is that just like we were returning S, but it was being assigned to a different variable. Remember, all of this is internal to the code. So I'm giving a different name here, but inside the code that will be treated like X. So it's as though I'm sending this in. X was just like a my block. So, this value will go in here and all this process will happen, right? So now if I run this, I get, let's see. So I get, so if I look at X decode, I expect it to be, is indeed Python is cool. And we can just, see how X swap mid rev, which was our X swap, say middle rev, was note plug C. So it basically took this thing, it reversed it first, and then it did a swap middle on that, and hence I could decode the string. Now, obviously, this is still a very simple example, but the point is we have to start simple and then build on, right? The number of algorithms, the number of encryption methods that you can build with just, these ideas is actually huge. But for all of them, you have to think of the decoding. So this was just to illustrate that, by using these simple building blocks, we can do more. In fact, we can have different kind of building blocks. We can do even more things, but always think of also the decoding. Now, I hope this entire journey has been fun for you. Like I said, this process of creating an activity which has this mysterious feel to it of this detective agency, of being a detective types, I think it's quite interesting. Explore, enjoy, be systematic, learn to practice, and you will just find this more and more interesting. Take care. Thank you so much. Bye bye.